So in this video, I'm going to show you guys a strategy you can use to find all real solutions to a polynomial equation. What that means is it'll get you any solution you can type in your calculator and get as a decimal, although it will not get you imaginary solutions. And we're going to be doing this primarily on the TI-84 graphing calculator. So, a lot of steps here. It's kind of like always though, it's the sort of thing where it looks like a lot, but once you learn how to do the process, it goes pretty quickly. So I'm going to give you a second to copy those down, pause if you need this for longer. I'm just going to kind of walk you through the steps through one example. So, let's say we were asked to solve this equation right here. According to our steps here, the first thing we want to do is make sure this polynomial is equal to 0. So if we're asked to solve, there's x to the thirds in here, it could be x squared, it doesn't really matter. You could even do this strategy on lines, but our basic idea is going to be just basically make it equal to 0. So we'll do our minus 3x squared and our minus 5, nothing too crazy here. We end up with x to the third minus 3x squared minus 42x minus 5 equals 0. Now, to give you guys a brief idea of what we're going to be doing here, picture for a second if this guy said y equals. Instead of there being a 0 there, pretend this was a y. What really happened then is that we plugged in a 0 for our y. When we plug in a 0 for y, that's an x-intercept, or a root, or a 0. We learned all those different vocab words for this same thing. So if we know where the roots are on this graph, or the x-intercepts, we know where the answers are. Now doing this by hand would be kind of a pain, and it would be hard to be accurate, but the nice thing is our calculator can give us the exact answers. So if you have your TI-84 handy, you're just going to go ahead and in the y equals menu type your equation in, and we're going to go to the graph from there. Now you can see that my graph right here, we know it's a cubic equation. So cubic equations are the ones that go in different directions. So maybe we'd be looking at something where it goes down like this and then it keeps going up, or in reverse. It's got the end behavior going in two different directions. And it appears based on ours that ours is starting low, it's coming up, then it's going back down, and eventually it's going back up again. So we're dealing with this sort of shape right here with our graph. Now, if you looked at our graph right there, there appeared to be 3 different roots on our picture. So I can see a root here, here, and there. Those 3 spots are my answers. So what I'm going to do before I kind of proceed here is try to make my picture look a little better, because right now it just looks like a bunch of vertical lines. There are a couple of ways of doing that. I've showed you before. You can use the zoom, and you can kind of zoom in and out until it works. Another option is the window, which is the second button right here. The window lets you specify exactly what x's and y's you want. X min, x max, y min, and y max. X scale you want to leave at 1 typically, and same with y scale. That's just how much your tick mark's going by. And you just kind of play around with the numbers here. My x's were fine, because I saw as far as I needed to going this way, but I don't see enough high points and low points right here. So what I'm going to do is just change my y min to negative 40, and my y max to positive 40. It's not like this is the only thing I could have done here, but it seems to work out okay, because when you look at the graph here, you'll see we can get a better view of what that shape looks like now. Now there's more to it down here obviously, but it gets the idea across. Now I'm going to show you guys the steps that I talked about on the last slide here. But before I do, I just want to point out really quickly, if you're like strapped for time on a multiple choice test, or if you forget how to do this exactly, we've used the trace key before to help us out. You can actually get pretty reasonable results just by using the trace key. So if I look and move my trace key as close to that root right there as I can, it appears to be somewhere in the neighborhood of negative 1.7. Similarly, I can look over here and be like, well, it's about negative 4.04 there. So you can eyeball the roots that way, but I'm going to show you the exact way to get your answers now. We're going to go to the calc menu, which is different than the one in the linreg that we've used before. You're going to hit second and trace. It says calc right there in blue. And the option we want is choice 2. It says 0, which we know already means a root or an intercept. We're going to go for this far left point first, just because that's what I decided to do. The first thing your calculator is going to do is going to ask you left bound. You want to make sure you're on the left side of this point right here. So you need an x value further this way. So all that really means for me is I'm going to hit left arrow once or twice, so I'm clearly on the left of it, and then I'm going to hit enter. The calculator will then ask me right bound. So I'm going to take my arrow key, I'm going to move to the right until I'm clearly on the right side of it. So I'm on the other side of this point right there. I'm going to hit enter again. And when it says guess, I'm just going to go close to the answer, hit enter one more time. It will think, and it will give me my exact answer right there. So my exact root is at -4. So if I were to make a very quick graph here, just to show you guys what's going on, we are looking at a graph that looks something very roughly like this. This answer over here is -4, 0. That means one of the solutions to this equation right here is x equals -4. So we have one solution down. Let's do the same thing now and get our second solution. So now I'm going to be going for this point right there, that root. I'm going to go back to calc, second calc, over to 0. And now left bound, I usually try to center myself on the root before I start. So I'm like right there. I'm going to go to the left of it, hit enter. I'm going to go to the right of it, hit enter. Guess, I'm going to go close to my answer, hit enter again. And when I do that, you can see the answer to this one is -1.62 thereabouts. So this point right here was a -1.62, 0. And that means x, and I'll use the wavy equal sign to show it's not exact. It's about -1.62 for our second solution. We have just one more solution to go. And again, we do the same thing. You go to calc. I'm going to choose 0 here. Whenever it starts asking you the questions, it's always a good idea to be on the point you want to have. So my cursor, I haven't seen it for a while right now. If you lose your cursor, just look at what your x is. Right now my x is at 5.95. And that's 1, 2, 3, 4, 5, 6, 7, 8. Almost between 8 and 9. So anyway, I'm just going to keep scrolling until I can see it. And finally that cursor shows up. Now, the left side is actually going to be this side right here. So I'm going to hit enter on left bound. Right bound, I'll hit enter again. And guess, it doesn't let me get any closer than that, so I'm just going to hit enter. And it gives me my final answer right there, which is 8.62. So once you find the x-intercepts, those are the solutions to the problem, we have our three answers right there, or the equation that we had above.